Hi everyone, today we're going to talk about stoichiometry, one of the toughest chemistry topics that you will face in your entire 2 years. Okay, and this stoichiometry is seemingly difficult, but it is simpler than you think. Why do I say so? Because if you look at this picture, as I always share in the class, I always say that stoichiometry is about recipe, it's about making food. So if you like to eat food, you know that certain time when the things are not being done correctly, so the food can be a bit more spicy, a bit more salty, or even a bit more oily. So if you talk about baking cake, okay, baking cake is also an art because you need to make sure that the amount of flour you use with the amount of sugar that you use, then plus the amount of milk that you use, will give you the flavor that you want for the cake. So the question is, what exactly is the correct proportion? So this is always the thing that baker will have to do many trial and error to figure out what exactly is the right amount. So, but in today's lesson, we're going to talk about what is the right amount for your chemistry equation. So if we do a bit of walking back to the mole concept first, exactly what is 1 mole? So if you recall, 1 mole of anything is 6.02 times 10 to the power of 23. And this has no unit because it really depends on what you're talking about. In the context of chemistry, that will be the number of particles you have in 1 mole. So when we take nitrogen, for example, that this is extracted from the periodic table, we have 2 masses that we need to know. So one is the mass number, then the other one is actually the number of protons or electrons, so given by the 7. And 14 is the thing that we're going to focus on from this point onward. And you remember that in chemistry, this is called the atomic mass. Which also means to say that this is, in fact, I would say, mass of 1 mole of nitrogen atom. So you will get a total of 14 grams. So what is 1 mole of nitrogen atom? It's basically 6.02 times 10 to the power 23. So this is that amount. It is quite pointless to count the mass of one atom because most of the time that is really very light. And in the case of measurement, it's also not very practical. So coming to the next concept, molar mass of the molecular mass. When we talk about molecule, what exactly is the total mass of a molecule? So if we talk about water, for example, then I would say that the mass will be 1 plus 16 plus 16, which equals to 33 grams. So this is for 1 mole of H2O molecules. Okay, take note, it's not for the number of atoms, but 1 molecule. Okay, 1 is about the H2O molecule. So 1 mole of H2O molecule will actually give you about 33 grams. So once again, going back to the point I was mentioning just now, it doesn't make sense to measure the mass of 1 atom, given that the mass of 1 atom is really quite little. So even though you're talking about the mass of 1 molecule, it's also going to be not much. So we look at 1 mole. Okay, using that as a concept, let's go back to our recipe creation part again. So balanced chemical equation is a chemistry way of looking at what do you need to produce what. And in fact, there's actually 2 things. I think number 1 is exactly what are you reacting. So we talk about the reactant. Then number 2 is what exactly is the products that's actually being formed. So these 2 things. So what do you react and what do you produce? And at the end of the day, we want to make sure that we use the correct proportion for the reaction. So let's take, for example, a neutralization reaction. So you want to neutralize, in this case, sulfuric acid with sodium, this is sodium hydroxide. So let's say you use sodium hydroxide to neutralize the acid. And at the end of the day, you will remember that we produce 2 things, which is namely salt and water. Okay, so Na2SO4 is the salt that you produce called sodium sulfate. And from there, the question is, after we have balanced the equation, meaning to say that right, we count the number of atoms needed, okay, as the reactant to produce the product that you want. Then after which, from the chemical equation, then we know that the recipe for creating the salt that you want is basically 1 mole of the acid with 2 mole of the NaOH that gives you 1 mole of the Na2SO4. Why? Because whenever we don't write a number in front, that just means 1. It's not 0. It cannot be 0. So every 1 mole of sulfuric acid will need 2 mole, 2 mole of sodium hydroxide in order to give you the salt that you need, which is also 1 mole. So this is the perfect recipe, the ideal situations. This is what you need, so theoretical. But the question is, exactly how much are we looking at if let's say you are given the actual quantity? So now if we move on to the next example, the concept of limiting reagent. So now if the question is, I give you 200 grams of sulfuric acid with 100 grams of sodium hydroxide, question is, what will be the amount of sodium sulfate that will be produced? So in this question, we need to look at exactly, do we have the things that's necessary for the reaction to take place? Do we have enough? If I say 200 grams with 100 grams, which will be the one that run out first? Or are we saying that both are extremely a lot, so you don't have to worry about which one will run out first? So in chemistry, by right, we have to determine this thing called the limiting reagent. So now, if we look at it, which one is the limiting reagent based on the mass given to you? And question number 2 will be, we need to calculate then the product based on the limiting reagent. Because if I run out first, the reaction stops. Then basically, I call the shot, I will tell you how much product you're going to produce. So now, let's determine which one is the limiting reagent first. So if we do a calculation of 1 mole of sodium sulfate, then we will actually get, sulfuric acid, then we will actually get 2 times 1 plus 32 plus 4 times 16, and then we get 98 grams. Then for the next one, we're going to calculate for sodium hydroxide. So sodium hydroxide will be 23 plus 16 plus 1, and that will be 40 grams. So take note that all these values are actually taken from your periodic table. Okay, we look at the mass number, so we take from the periodic table. Then after that, okay, so 1 mole, exactly for 200 grams and 100 grams, how many mole are we looking at? Right, so this is the actual. So if we want to find the actual number of mole that we have, so I will take what you give me. I tell you that 1 mole is 98, right? So 200 has how many 98? So we get about 2 mole. Okay, then we do the same thing for the other one, which is the sodium hydroxide. We get about 2.5 mole. Question, which one is the limiting? Right, so you have to make an assumption. Right, you have to make an assumption, am I going to finish the sulfuric acid, or are we going to finish the sodium hydroxide? So now we look at the next line. 2.04 mole of sulfuric acid will need 4.08 mole of sodium hydroxide. So I'm making an assumption. I think of it as the reactant number 1. The sulfuric acid is the one that I will completely use up. Then I will see how much I need for the sodium hydroxide. Then you notice that, wow, 4.08 mole, do I really have that? If you look back at the previous calculation, the only thing we have was 2.5 mole of sodium hydroxide. So the answer is quite clear that, sorry, we don't have enough. So I will say that NaOH is the limiting reagent. From here on, we look at the proportion of things based on the equation to see whether what will be the proportion of salt we're going to produce. So looking back at the equation now, you will be able to see that by the ratio of mole, every 2 mole of sodium hydroxide will produce only 1 mole. So the ratio is 2:1. Meaning to say that you always need to use more sodium hydroxide, similarly, to produce the salt that you want. It's a 2:1 ratio. So by that, if we look at the calculation now, quite simple. You know that you're going to use 2.5 mole of sodium hydroxide. So you just need to divide by 2. So by ratio, you will see that 1.25 mole of sodium sulfate will be produced. But take note, we use the mole ratio, not the mass ratio. Okay, the elements, molecules, they all have different mass. You're going to use the mass ratio, it's not going to give you the correct answer. So you have to use a mole ratio to do this calculation. Okay, I hope you find today's video useful. So I introduced the idea of limiting reagent, of how we can get it from the balance equation when you are given the actual mass. So this is one of the very key important concepts in chemistry that you will be using it to determine the actual quantity of substance that you would need for the calculation. In the future video, I'm going to talk about how we're going to use volume of gases to figure out what is actually the quantity or mole ratio that you need. So if you're interested, you can actually watch my next episode on that. So before that, thank you for watching the video. If you like our video, please help to share and like. If there's any questions that you want to ask, please feel free to comment. I will try to explain to you as soon as possible. Thank you.